Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to YouTube channel Chandan Physics. In this video, we are going to discuss conductivity and mobility of semiconductors. Let's begin. Let us consider a semiconductor. It's a semiconductor whose length small l length of semiconductor capital A be the area of the cross section in that of particular semiconductor. The number of electrons, that is denoted by n of E, number of electrons. Similarly, the number of holes, n of H, number of holes. We know in the classification of semiconductors as pure type and impure type, that is intrinsic semiconductor, which one is pure, extrinsic semiconductor, which one is impure, means impurities is added. On that of basis, we classify that extrinsic semiconductor into two categories. One is n type semiconductor and another one is p type semiconductor. In case of n type semiconductor, free electrons are the charge carriers. In case of p type semiconductor, holes are the charge carriers. For that purpose, n is the number of electron, nh is the number of holes. And we apply a potential difference V. V is the potential difference is applied throughout that of semiconductor in order to flow the electrons as well as holes. Due to that application of potential difference, a current is flown through that of semiconductor. Therefore, the total current I is given by I is equal to I of E plus I of H, current due to the flow of electrons and also the current due to the flow of holes, whereas IE current due to flow of electrons, I of H current due to flow of holes. or total current I is equal to IE plus IS. In case of IE, that is N E A E V E, whereas N E number of electrons we know, A area of the cross section, but E charge of electron, it is the electronic charge, VE, which one is the drift velocity of electron, drift velocity of electron, plus I of H, and is N P number of holes, area of cross section, electronic charge, and V of H. Here V of H, that is the drift velocity of holes, or current I is equal to, we take common E A E as common, inside that bracket N E V E plus N P that is N H V H, N H number of holes, N H V H, okay. Or now A is divided to this side, so I by A is equal to E whole into N E V E plus N H V H, but we know I by A, current divided by area, is nothing but current density. Current density J is equal to E N E V E plus N H V H, where J is equal to I by A, that one is current density, current per unit area. Again we can calculate that particular expression in terms of conductivity. As you know, J, that one is the current density, is the product of electrical conductivity and electric field intensity. J is the product of electrical conductivity and electric field intensity E, capital E. Here is the electronic charge N E V E plus N H V H, where J is equal to sigma into E, where sigma electrical conductivity and E electric field intensity. electric field intensity. Therefore, sigma is equal to that A is divided N E E V E divided by E plus N H E V H divided by E, or sigma is equal to N E E V E divided by E. Drift velocity to that of electric field intensity is nothing but mobility. For drift velocity of electron to that of electric field intensity is known as the mobility of electrons. It is denoted by mu E. Similarly, drift velocity of holes divided by electric field intensity, that is nothing but mobility of holes. Here mobility of electrons, that is mobility of holes. N H E mu H, that we write it V E by E, V of E divided by E is equal to mu of E, is V of E, mobility of electron, mobility of electron, and V H divided by E, that is mu of H, which is mobility of holes, mobility of holes. That expression electrical conductivity how related to mobility. But in experiment we know the mobility of electron, the mobility of electron mu of E is greater than the mobility of holes. The mobility of holes is mu of H, that is mu of E is greater than mu of H. Therefore, thus the current, i.e. current due to that of electron, is also greater than that current due to the holes, as current related to that of mobility factor. Current of electron is greater than that of current of holes. Again, there are two types of semiconductors. This is a overall relationship in between conductivity and mobility of semiconductors. If we calculate it in terms of n type semiconductors and in terms of p type semiconductor, so the expression the electrical conductivity of n type semiconductor that is sigma of n is equal to n d e mu e. Whereas ND is the number of donor impurity, number of donor impurity, number of donor impurity atoms per unit volume, number of donor impurity atoms per unit volume. In n-type semiconductor, we use the donor, which one is a pentavalent donor, and free electrons with a charge carrier in n-type semiconductors. So, a factor Nd, that is the number of donor impurity atoms per unit volume. Next, electrical conductivity of p-type semiconductor. And the electrical conductivity of p-type semiconductor. In p-type semiconductor, the impurities is a trivalent impurity. So, sigma of p is equal to let n of a, here that is the number of donors, but at that of case that is the number of acceptors, E mu h mobility due to that of holes. In case of p type, hole as the charge carrier. In case of n type, electron with the charge carrier. Therefore, Na, that is number of acceptor atoms, acceptor impurity atoms, acceptor impurity atoms per unit volume, per unit volume, number of acceptor impurity atoms per unit volume. That will be the expression for electrical conductivity and mobility for n-type semiconductor. Similarly, electrical conductivity and electrical conductivity and mobility for p-type semiconductor. So, with the help of this video lecture, we understand the concept of conductivity and mobility of semiconductors. We consider a semiconductor, length L, area of the cross section A, number of electrons Ne, number of holes Nh, potential difference V is applied, the total current due to that flow of electrons as well as flow of holes IE plus IH. So, IE, that is Ne, A, E, VE, Ne number of electrons, area of the cross section, electronic charge, Vs, Ve, the drift velocity of electron. Similarly, for that of a hole, that one is Nh, A, E, Vs. Simplifying it, I by A are the current density are the product of electrical conductivity and electric field intensity. Finally, that will be the expression for conductivity as well as mobility for semiconductors. As we classify the semiconductor into two categories, one is n type and another one is p type. IE is greater than IH due to the mobility of electrons is greater than that of mobility of holes. For n type, that is the electrical conductivity as well as mobility. For p type, electrical conductivity and mobility relationships. In n type, mu d is the number of donor impurity atoms per unit volume, which is Nd. Na, here is the number of acceptor impurity atoms per unit volume. In case of n type, it is donor, for in case of p type semiconductor, it is acceptor. So, with this useful and informative notes, let me wind up this session. Thank you.